To really know what makes a great city work, you have to peel back its skin and expose its secret life force. A system of incredible complexity and technology that millions depend on, but few understand. A fantastic voyage now begins, a journey deep inside the world's megacities. They call it the City of Lights. Yet Paris has a dark side. In one of the world's tourist meccas, it's a sight few ever see. It lies just beneath the surface, hidden from view. The bowels of Paris. The vital organ of a city with the world's richest cuisine. The surface world binges, the netherworld purges. And neither can survive without the other. Today, the window to the City of Lights is a manhole. These are the sewers of Paris. They extend for 2,300 kilometers, the distance from Paris to Istanbul. Every day, these tunnels carry away 1 million cubic meters of human waste. Enough to fill the Empire State Building. Without them, the most beautiful city in the world would drown in a river of its own filth. From this 19th century infrastructure sprouted a sprawling metropolis. Yet as the surface world thrived, the netherworld gasped to keep up. For Paris to survive, this ancient system must chart a new course. The challenge is, harness technology to streamline a black labyrinth. Tap science to cleanse an ocean of sludge. And recruit a new breed of workers, not just to maintain the system, but to reinvent it. To connect an ancient city with the new millennium. And Paris must do it all in the dark. The Paris sewers are a parallel metropolis. A photographic negative of the streetscape above. It's one of the largest sewage systems in the world. Yet in a megacity of more than 11 million people, the sewers are maintained by fewer than 650 workers. Thanks to far-sighted design and brilliant engineering, gravity does most of the work. Sewage moves downhill en route to treatment. It starts in pipes the diameter of a saucer and ends in tunnels the size of a house. In low-lying areas, pumps help move the flow along. The entire system is linked to the surface world by 18,000 drains and 30,000 manholes.
These are the best-built sewers in the world.
Pride is as French as wine and brie. But Philippe Bouzigny has reason to be proud. The sewers of Paris are not only exceptional, they're logical. Every sewer tunnel corresponds exactly to the street above. Not just in direction, but size. Wide tunnels for grand boulevards. Narrow tunnels for side streets.
What we can say is that in every sewer, there is the name of the street above. That way we can see where we are. In the sewers, if we didn't have these signs, we would get lost. Even people from our department who are used to it get lost. The sewers are a real labyrinth.
A labyrinth in need of constant repair. For decades, the Paris Sewer Authority has struggled to maintain this maze of pipes and tunnels. In a system where defects can mushroom into disaster, every meter must be regularly inspected for cracks, holes and leaks. Yet the maps used for inspections were as ancient as the sewers. Then Paris began to digitally map this labyrinth. Today, you can fit the entire sewer system on a single hard drive.
The TIG system represents a whole network of sewers in Paris.
Every day, Vincent Evrard navigates the underworld without leaving his desk. His guide, an innovative software program called Tigre.
So we can see from this model a number of things, like the river Seine going through Paris, the quarries, the whole sewer system.
The entire sewer system is broken into 28,000 sections, each identified by a street address. Impressive as the map is, Tigre is much more. At the touch of a button, Vincent can pull up a status report on any section of sewer.
So here we are at 43 Copernic Street.
This section hasn't been inspected in months, yet within hours, Vincent will know whether it's intact or in trouble. Twice a year, every section of sewer is visited and a report filed. Tigre sheds light on Paris's netherworld and illuminates trouble spots. Without this data, the entire sewer system would collapse. But to gather the data that makes Tigre work, someone must leave daylight behind. Alain Allemand is a scout on the front lines of Tigre. Each morning he walks a different route, 1.5 kilometers long, looking for trouble.
Paris underground is like Swiss cheese. There's the metro, the cables, the underground network. So we have to monitor all this. And especially where the sewers go through, because any water infiltration will degrade the ground, and those incidents could be serious. The biggest problems that occur are cracks due to the shift in the ground and vibrations.
Alain used to write reports with pen and paper, then mail them in. In a system where today's crack can become tomorrow's crisis, time counts. Pen and paper are out, handheld and wireless are in. Back at Tigre headquarters, Vincent gets the update.
On Copernic Street we had a visit this morning, and they sent us information about a leak of drinking water in the sewer. Which appears on these monitors as symbols that indicate we have to either replace or fix something.
Once the data is logged, Vincent can dispatch another team to fix the problem. One leak plugged, one disaster averted, thanks to the marriage of a venerable system with new technology. Technology is changing more than how the sewers are maintained. It's changing their very purpose. Today, information is a megacity's most precious commodity. And in Paris, information now flows through a whole new pipeline. Is this any place to do business? In the City of Lights, it is. This is the legendary delivery system Parisians call pneumatique. Like the sewers, this infrastructure was designed in the Victorian era. The first lines were installed in 1866. A century before the age of faxes and email, This was Paris's first wireless communications technology. The concept? Move information at high speed. The mechanism? A black hole and a black box. To mail the cartridge, you punch in the code of the destination.
Every cartridge is indexed. Every station, departure or arrival has a specific code.
A simple code. Each address is represented by a series of numbers and letters. Claude Picard has used it for more than 20 years. Today, he's sending documents from City Hall to the main post office.
It's on post B1, which we find on line B. Then number 1. Then the cartridge is sucked in. There it goes.
To lay the conduits for the pneumatique, not a single meter of Paris's fragile streetscape was torn up. The entire route for the conduits already existed. The parallel metropolis underground. A city-wide infrastructure matching the famous streets above. The sewers. Powered by compressed air, the cartridge zips across Paris at 36 kilometers an hour. All thanks to the sewers, Paris's first information superhighway. The pneumatique also pioneered another first: package tracking.
An arrow lights up on line B, the number 1, to show where it is.
Operated by the Postal Service, the pneumatique was a public service available to any Parisian. Once, 10 kilometers of tubes ran through these sewers. Today, there are only 7. The system is mainly used to send original documents between a handful of government buildings. Like every piece of technology, the pneumatique was overtaken by progress. Today, it's easier to send a fax or an email than a cartridge. But now comes another French revolution in technology. Paris wants to be liberated from paper, from tubes, even from wires. And liberation requires a new system. The technology is called wireless fidelity, or Wi-Fi. Before Wi-Fi, if you wanted to hook up to the internet, you needed a wire. Not anymore. With full Wi-Fi coverage, you could link to the internet in thin air, anywhere in Paris. Data is transmitted wirelessly, like a radio signal, from an antenna straight to your computer. Yet the antenna's range is limited. For full wireless coverage, Paris needs a whole network of antennae. Here's the irony. While the antennae transmit wirelessly, they all have to be wired together to the internet. But in Paris, wires and aesthetics are on different wavelengths.
Paris is a beautiful city with a lot of historical monuments we have to preserve.
Pierre Barnabé is vice president of Alcatel, France's leading wireless provider of telecommunications equipment. His challenge? Install a network of Wi-Fi antennae throughout Paris, without scarring the city's fragile facade. Once more, the solution lies in the sewers. Meter by meter, fiber optic cables are extending their reach. One day, these slender threads will weave together every house, office, store, restaurant, and apartment building in Paris. Meanwhile, high above the city, Wi-Fi antennae are sprouting all over Paris. Wireless flowers, fertilized in the filth of the sewers. In time, the sewers will carry enough fiber optic cable to link a complete network of Wi-Fi antennae. The antennae will create an overlapping series of coverage areas, or hotspots, until the entire city is connected. Wirelessly, Parisians will receive email, video, and data at lightning speed. All thanks to the sewers. Georges Costa is a soldier in the wireless revolution.
We are in the process of installing fiber optic cables comprised of 12 threads. We are using the sewer system so we don't have to dig up the streets.
Georges works with the telecommunications company Completel. Today, they're trading utility poles for sewer pipes. Several hundred times a day, he goes through his ritual. Drill a hole, install an anchor, apply resin for waterproofing, attach the cable.
And after that, the cable is secure for years.
It has to be. Water and wires don't mix.
We are in a wet environment, and as you can see from the cable that have been here for a long time, they are completely ruined. So the cable we lay in the sewers is reinforced. And it's rodent-proof, because the first problem in the sewers is rats.
The second problem is gas. Sewage contains methane. If too much methane builds up in too small a space, it can spontaneously explode. Even at low levels, methane is dangerous. By choking off oxygen, it can cause blackouts, even death.
So we bring the cables outside to do the connection, and when we are done, we bring them back down.
The cable is actually a bundle of fine fiber optic threads. Each must be perfectly fused at high temperature.
Once the fusion is complete, the machine will give us data on the quality of the fusion.
To protect the delicate fusion, Georges reinforces it with a metal rod and wraps the threads in a waterproof casing. As they say in Paris, voila. Another day, another connection. Meter by meter, Wi-Fi cables unspool across Paris, stitching this megacity together in an unseen tapestry of technology.
Look around. You'll barely see any cables. Everything is underground, which is exceptional and pretty much invisible.
Exceptional and invisible, but incomplete. Some tunnels are too small for human hands to reach. The solution? Downsize the workforce. This is a cable-laying robot. The cutting edge of remote access technology. As versatile as it is compact, this machine can multitask, pull wire, make splices, even check its own work.
It's an incredibly complex piece of equipment. It took over 3 years to develop the robot itself.
Jack Connie is the founder and president of K-Botics, an American firm that lays fiber optic cable in sewers. He's come to Europe to demonstrate what his robot can do, and the Paris sewers are the acid test. To prevent corrosion, each component of the robot is vacuum sealed to keep out moisture.
In addition to that, there's a gas detector which detects any type of high methane or explosive environment in the sewer. Should there be any type of trace levels, it automatically shuts the robot down.
If all's clear, Jack starts laying cable, just like Georges Costa, except Jack works by remote control.
The mechanism for assembly pivots to where the drill is located to the exact location of the fiber anchor. The drill goes up, is deployed, it drills through the hose pipe, it retracts, then the assembly pivots, it grabs the fiber cable, and then uses a polybutane anchor and places that flush against the hose pipe.
In a single 8-hour shift, the robot can lay 800 meters of cable.
If you worked at 24/7, you can do the math numbers, and it's just a little bit under a mile, the fiber that can be deployed.
Working round the clock, human crews could lay no more than 100 meters of cable a day. With a crew of 10 robots, you could wire the entire city in just 3 months. For now, it's a good day's work. Jack withdraws his assistant and packs up, leaving no trace of this American robot in Paris. Cable-laying robots will soon be toiling throughout this labyrinth. But to maintain this warren of tunnels, another crew is already on the job. Laborers with guts of steel, heedless of danger, immune to the diseases of this subterranean world, equipped to go in tunnels where no man can follow, and built to see in the dark. Tunnels don't frighten these crews. They're waterproof, corrosion resistant, and they come in 3 sizes. They're Paris's ultimate sewer workers. On the streets of this megacity, more robots are rolling to work. Jean-Pierre Cornu works for Hydrovideo, a French company that provides inspection robots to the Paris Sewer Authority.
Here I have the biggest of the robots for inspecting pipes of diameters of 150 to 1200 millimeters or more, depending on the accessories. Here is a robot a little bit smaller that lets us inspect smaller pipes. And here, an even smaller robot that lets us inspect pipes 100 millimeters in diameter.
Pipes no wider than a coffee cup. Equipped with a camera and operated by remote control, the robot can check a connection for cracks or leaks. Like its cable-laying counterpart, an inspection robot is armed with a blade. It's used to scrape off mineral deposits and cut roots that have penetrated a pipe. Jean-Pierre can monitor his workforce by remote, up to 1,000 meters. Whatever the robot's position, he gets a clear view.
I can rotate it 360 degrees or 180 degrees perpendicular to the axis of the pipe, and the image from the camera always stays horizontal.
Using a laser, he can measure any flaws the robot finds, such as cracks. In a newly installed pipe, he can measure the angle of incline to ensure that gravity can do its job. Today, he's checking the connection between a sewer main and a residence. If he finds damage, he can send in another robot to make the repair. In time, robots may handle not only the smallest jobs, but the dirtiest. For now, the indispensable sewer worker isn't made of wires and steel, but sinew and bone. And every day they put their lives at risk. To keep the arteries of this megacity open takes shrewd judgment, brute strength, and iron nerves. But when the unexpected happens, man is no match for a force of nature. On a clear day in the City of Lights, it's hard to see the dark side, but it's there. Even the city's very icon hides its true nature. Every year, 6 million tourists come to gawk at the Eiffel Tower. But behind its breathtaking iron facade, some dirty business goes on.
We have here all the technical services. The drain pipes for used water, toilets, sinks, restaurants.
To engineer Jean-Alex Fauré, the tower isn't a monument, it's a living building with bodily functions.
We arrive here above the second floor, above the Jules Verne restaurant, where all the pipe systems arrive and wrap around to continue their route over there. And they continue to follow the curve of the tower and go all the way up to the top floor.
7 kilometers of plumbing serving 2 restaurants, numerous water fountains, 20 urinals and 40 toilets. Like the entire city, even the Eiffel Tower must answer nature's call. What goes in must come out. But here, it happens with a certain je ne sais quoi.
Ah yes, the highest toilets in the world for at least half a century. It all starts here and works its way all the way down to the bottom, to the sewers of Paris, somewhere down there.
Gravity brings wastewater down to the sewers, and gravity keeps it flowing. Across its length, the city gradually slopes toward the River Seine. Side tunnels feed into sewer mains, all heading toward the lowest point in the city. At a handful of depressions in the terrain, pumps help move the flow along. Thanks to gravity, the sewers are largely self-operating, but not self-cleaning. Left unattended, like a toilet never flushed, they back up. Sewage would literally flow through the streets, as it did for centuries. In its wake would flow a tidal wave of disease. Each morning, while much of Paris still sleeps, platoons of sewer workers marshal against the forces of filth. It takes a small army to keep this system from clogging up. And these workers man the front lines. Their workday starts around 6 a.m. As Paris awakes, so do the sewers. As the hours pass, the trickle becomes a torrent. The cleaning crews have to work fast. The water rises fast and high. By noon, they could be up to their necks in sewage. What a way to go. Sewer workers are like miners. They toil in dark places. They breathe bad air. They risk death from explosive gases like methane. They lose years to diseases like cancer and emphysema. The average lifespan of a sewer worker is only 57 years. Sewers carry other risks found in few mines. Tetanus from dirty needles, diseases from rats, and death from drowning. Dressing for work is like girding for battle. Respirators, gas detectors, and a drowning hook.
The harness is just in case of an accident. The hook is attached here, and it holds you by the back, and it has a hook to rescue you. And voila, you have the perfect sewer worker ready to go to work.
The sewers are meant for sewage, not garbage. Yet every day they carry waves of trash.
A hubcap. We find everything in the sewers. We find objects that people throw out. I'm not even counting bottles, cans and stuff like that.
A backup of trash could clog the system. But large debris is easy to remove. As always, it's the small stuff that can cause the biggest problems. Each year in Paris, millions of tons of sand is used in construction projects. When it rains, the sand washes into the sewers and slowly collects.
Here we are in front of a basin to remove sand. It's through here that we're going to trap the sand that comes from various sewers. When it's full, we dry it and we remove the sand through this trap towards the exterior, either by vacuuming it or with a system of cranes to remove all the heavy stuff.
But tons of sand escapes the sand traps. Each year, sewer workers remove enough sand and sludge to fill 10 Olympic swimming pools. They do it using a piece of technology that hasn't changed in a century. The bateau van, the flushing boat. Like the sewer system itself, the bateau van harnesses the natural force of moving water. Simple wooden wings attached to the boat create an artificial dam. As water rises behind the wings, pressure builds, pushing the boat forward. The higher the water level rises, the more the pressure builds. A large blade in front pushes sand and grit into piles for workers to collect. The water behind the boat creates such enormous pressure, heavy chains are needed to keep it from drifting away. As the boat progresses, the chains are released, then reattached. It's like a water-propelled snowplow, a filthy 10-ton snowplow.
We still haven't found a better way to clean the sewers.
Richard Jourdain leads a flushing boat team. Today they're cleaning a 50-meter section near the famous Paris Opera House. Before they can start, they have to rescue the boat itself from a flood of filth.
Every morning the boat is in deep. We clear it out with trash cans and we empty out the boat in the opposite direction that it came. It's the worst when the boat sinks. After a storm, the water level rises and sinks the boat in. Voila!
Storms can sink the workers too. Outside, rain has started to fall. This means trouble down below.
It's very dangerous. The water goes up, 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 up without stopping. And you see those things. That's debris that's attached itself to the metal railings from the water, from when it filled up all the way to the roof. The danger in the sewers are the storms that cause all this.
If caught in a low-lying section during a sudden storm, you could be swept away in a flash flood. But even down here, you can find higher ground. Refuge chambers built into the sewer system.
We're situated about 5 or 6 meters above the collector. It's the area where we protect ourselves in case of rapidly rising water or a storm, like for example here, when there was a great flood of 1910. The water came up to this level. It's the only place we can go to protect ourselves.
When you work in water, drowning is always a risk. At some point during his career, nearly every sewer worker falls in. It's the worst kind of river. Dark, foul, and fast. In an instant, your protective suit can become an anchor around your neck.
When you fall in, the jumpsuit fills up with water and your weight pulls you to the bottom.
Right now, it's the flushing boat that could be swept away.
There are two guys on both sides of a bank. There is one operating the blade and two more on the back operating the chain. The people who work on the boat, they know the dangers. The people on my boat, they warn me. And we adjust the winglets. You see why I say it's dangerous.
The winglets are the throttle. Too little pressure and the boat goes nowhere. Too much pressure and the boat gets away. 7,000 kilograms of machinery out of control.
Sometimes there is so much pressure, we have to stop the maneuver. Because the water rises so high, we can only work with 1 meter of water behind the boat. Above that, we lose security.
Despite the precautions, danger mounts. Pressure builds. Chains strain. It's too much. A chain snaps. So do bones. The boat has broken loose, and Richard is down.
They'll take him out and take him to the hospital. The hardest part will be getting him out. They'll have to get a winch and a stretcher or something like that.
Is he injured?
Are you kidding me? He broke his wrist. The chain with the stress broke loose, flew up, landed on his arm, paf, broke clean. He's here.
In the sewers, accidents can cut short an already brief life. Richard is lucky. Today he needs a doctor, not a priest. This is the hidden cost of keeping this megacity flowing.
We work in hostile environments. If we were in a team and worked together, paid attention to one another, then we'd have a lot more accidents than just that. It's a very, very dangerous occupation.
The Paris sewers carry waste, wires, and Wi-Fi. They link this megacity in ways their builders never imagined. But it's still not enough. The system is burdened with one more challenge. In a city of asphalt and concrete, rain has nowhere to go but the sewers. During a torrential downpour, the flow underground can triple. The sewers can literally overflow. Now, the water has nowhere to go but into the streets, unless you install a safety valve. When it rains in Paris, sensors in the main sewers constantly measure the water level. If it rises too high, the excess flow is channeled from the most saturated sewers to the least. If all the sewers become saturated, the excess flow is channeled into half a dozen large reservoirs across the city. When the storm subsides, the overflow from the reservoirs is pumped back into the sewers. But heavy rains can saturate the entire system and activate the failsafe. 45 waterways linking the sewer system to the River Seine. Automatically, gates open, and the overflow is discharged straight into the river. The gates are the only safeguard between deluge and disaster. This is one of the gates that lead from the sewers to the Seine.
This gate is normally operated automatically, but it's the start of winter, so today we are double-checking that it's working.
Christophe Dalloz is director of the automatic management of Paris sanitation. His job, to keep the sewers out of the streets. During heavy rains, sewage used to back up into basements and boulevards. Now Paris has an escape hatch, the river itself. It's a dirty trade-off. The overflow released into the Seine is filtered, but not treated. The choice is stark. Send raw sewage into the river or into the streets.
So what we're trying to do, as much as possible, is to avoid this from happening. All these releases lead to a very important question. How far do we go to protect the river?
For Paris, polluting the river is the lesser of two evils. On average, about 4 times a year, the city is forced to make that choice. It's another dark side of the City of Lights. But a century ago, this worst-case scenario played out every day. Raw sewage was released right into the river. Just as the sewers rescued Paris in the 19th century, sewage treatment plants rescued the Seine in the 20th. But in the 21st century, the technology of turning the unspeakable into the drinkable has changed course. Today, to cleanse a river of filth, you have to swim against the current of outdated technology. Pierre Ferreira should be the most unpopular man in Paris. He runs a sewage treatment plant in the middle of a Parisian suburb. But if you followed your nose, you'd never find it. This is Colombes, one of the world's most technologically advanced treatment plants.
It's a very modern plant in a city environment, and the main challenge was to emit zero pollution.
The first job of any treatment plant is decantation, separating liquids from solids. In traditional plants, decantation happens horizontally over many hectares along a series of giant basins all open to the air. It's a costly way to dispose of something worthless. The plants are expensive to build. They occupy huge tracts of land, and they stink. At an experimental plant like Colombes, they enclose the whole system and stand the process on its head. They treat sewage vertically in a completely self-contained system.
This plant is different from others. It's a cube, 150 meters wide, 150 meters long, and 26 meters high. In this space, we can treat just as much as a classic plant that covers 2 to 3 hectares.
Because the plant is vertical, sewage moves through it faster than it does at a conventional plant. Gravity and pumps do most of the work.
This way, we can increase the speed and efficiency by 5 times. So we can pump out more than a normal plant.
As Paris grows, older plants are expanding to handle the flood of sewage. But the wave of the future is Colombes. Smaller plants with a high capacity and few drawbacks. It's a high-tech magic act for sewage. What goes in doesn't come out.
The waste is incinerated in ovens, like the one you see on my right and the one I'm standing on. The waste is introduced at the bottom and then brought to a temperature of 850 degrees Celsius and then it transforms into smoke.
Particles in the smoke are filtered and trapped. Result, the smoke released from Colombes is harmless, odorless, even smokeless. At enclosed plants like Colombes, you see no evil, smell no evil.
We have had no complaints from the neighborhood. This is a clean plant. Everything that's released in the atmosphere is neutral.
In the final stage, treated water goes to the River Seine. Here, the cycle comes full circle. Every day, 300 million litres are siphoned from the Seine and pumped to a water treatment plant to slake the thirst of Paris. Today, Paris's most vital organ is its sewer system. In this netherworld, the megacity is both purged and wired, cleansed and connected. While the old guard put their lives on the line, new recruits join the war on waste. As the never-ending battle rages, this ancient system reinvents itself for a new millennium. So long as this river flows, Paris can see light at the end of the tunnel. When the underworld thrives, the surface world glows, just as a light brightens when darkness falls. In the city of lights, such is life. C'est la vie.